In this video, we're going to talk about different types of pedigrees, or how to identify what type of inheritance pattern a pedigree follows. Okay, so what we're going to look at is different kinds of inheritance patterns, and we have little checklists on how to identify those inheritance patterns. So these notes will be very, very helpful when you're working on any kind of pedigree identification. Okay, so we generally are going to do this in like a stepwise function. Okay. The first step to determining what type of pedigree chart you're looking at is to determine whether it's autosomal or sex-linked inheritance. So that's going to be the first question that you ask yourself, autosomal or sex-linked. So the main way to identify the difference there, okay, is autosomal means that it's going to be found on any chromosome that is not a sex chromosome. So any chromosome that contains a genetic trait that is not one of the sex chromosomes, so not the X or Y chromosome. So generally what this means is autosomal traits are going to affect males and females fairly equally. So the first question you're going to ask yourself then is, are males affected more or females, or does it affect both? Now, if you have a sex-linked trait on a pedigree, that's going to be a genetic trait that is found on one of the sex chromosomes, so either the X or the Y. So these kinds of traits are generally going to affect one sex over the other. So that's the first thing that you're going to look at in order to be able to identify what kind of pedigree you're looking at. So in general, a pedigree that's autosomal is going to show about a 50-50 ratio between men and women being affected. Now, that's not always going to be a perfect 50-50 ratio. So you might see like slightly off of 50-50, like 4-2 or 3-2 or something like that, but it's going to be fairly equal. You'll be able to see if something affects one more than the other. So when you have an autosomal dominant pedigree, okay, this will be the list of things that you're going to look for in order to identify it as an autosomal dominant pedigree. Okay. So first, the trait that you're looking at, okay, is going to appear in both sexes equally. Both sexes can also give the trait to their offspring, and it's not going to skip generations since it's a dominant trait. Okay, dominant traits, you only have to have one copy of the gene in order to show it. So if you've got that one, you're going to have the trait. So that's why it doesn't seem to skip any generation. So if an affected parent has it, they're going to pass it on to their offspring. Now, that means that on any kind of pedigree that you want to identify as autosomal dominant, you need to see affected offspring having an affected parent. Okay. Now, in addition to that, this is one of the more unique things that will really identify a pedigree as autosomal dominant, and that is when one parent is affected and heterozygous, and the other parent is unaffected. Now, slight disclaimer here, okay? On a pedigree, you're not always going to know if a person is heterozygous for a trait. So you kind of have to infer the fact that they're heterozygous by looking at what their offspring have. Okay. So when one parent is affected and is heterozygous, and the other parent is unaffected, about 50% of the offspring will be affected. So if you're looking at a pedigree and you see an affected parent that mates with another unaffected parent, okay, and you see about half of their children are affected, then you should be thinking autosomal dominant. Now, one thing to remember with autosomal dominant is unaffected parents absolutely cannot transmit the trait to their offspring. Okay, so you will not have any affected offspring if the parents both are unaffected. So an example of a disorder that follows this inheritance pattern is Huntington's disease. So we talked about that before in the previous sections of this chapter. We described Huntington's as a simple dominant inheritance pattern. So that simple and autosomal are used interchangeably. They mean the same thing. So again, it just means you have to have one bad copy of that gene in order to show that disorder. Now with autosomal recessive, you're going to have some of the same characteristics, but there's a few that are going to set it apart, that are going to identify it as recessive. So first thing, you're going to see it in both sexes fairly equally. That's the same because that's autosomal. Now, the main difference here is the traits are going to look like they skip generations. So you might see affected parents, then some unaffected children in generation 2, and then maybe some affected grandchildren in generation 3. So it looks like it skipped that second generation. Now, affected offspring are usually born to unaffected parents in an autosomal recessive pedigree. So generally those parents are going to be a carrier, one or both of those parents could be a carrier for that particular trait and pass it on to their offspring, even though they don't show that they're affected by it. Now, if both parents are heterozygous for a trait, about 25% or a quarter of their offspring will be affected. Now, again, you're not going to know for sure if they are heterozygous, but if you see two parents that don't show a trait, okay, remember this is a recessive trait, so if they're heterozygous, they're not going to be showing the trait. If you see two parents that look like they're unaffected in the pedigree, and about a quarter of their kids are affected, you should be thinking autosomal recessive. Now, autosomal recessive disorders and traits will tend to appear more often in inbred mating because when inbreeding happens, okay, when you start to mate within the same family, you start to mate within the same gene pool. So there's not a lot of variety of genes to pick from, so these recessive traits start to show up more. So an example of a trait that would follow this inheritance pattern is cystic fibrosis. So again, we talked about that one in the earlier sections of this chapter. So along with that, PKU and Tay-Sachs disease, like we talked about before, would also be autosomal recessive examples of disorders. Now, on the other side, if the pedigree is not autosomal, if it is sex-linked, okay, it could be linked to either the X or the Y chromosome. So if a pedigree chart shows a trait that affects one sex over the other, so affects males more, or they sometimes can affect females more, then that's going to lead you to believe that it is an X-linked pedigree. So for X-linked dominant pedigrees, what you need to look for first is that you do see both males and females affected, but females are going to be affected a little bit more than males in this type of pedigree. Now, that's mostly due to the fact that females have two X chromosomes, so they have a higher chance of inheriting an X-linked dominant trait because they've got two chances to inherit a bad X chromosome. Okay. Males don't exactly have that kind of probability because they only have one X chromosome. Now, again, this is a dominant trait, so it's not going to skip generations. Now, there are a few unique things to look for with X-linked dominant. So the next few things are going to be like your telltale signs of seeing an X-linked dominant pedigree. So that first thing of those telltale signs is that affected sons must have an affected mother. Okay, because sons get their X chromosome from their mom, their Y chromosome from their dad. So if the son has the trait, he had to get it from his mom because that's where the X-linked comes from. Okay, so in order to have an affected son, you have to have an affected mother. Affected daughters have to have either an affected mom or an affected dad, okay, because they get one X chromosome from their mom, one X chromosome from their dad. So they have to have at least one affected parent. And if you have an affected father, they're going to pass the trait onto all of their daughters, okay, because they only have one X chromosome to give. And if it's affected by a dominant trait, they're going to give that X chromosome to their daughters, and all those daughters are going to show that dominant trait too. So if you see an affected father and all of his daughters are affected too, you should be thinking X-linked dominant. That one is probably going to be the biggest indicator of an X-linked dominant pedigree. Affected mothers, if they're heterozygous, they will pass the trait on to half of their sons and half of their daughters. Now, again, with that heterozygous, you won't know for sure if they're heterozygous, but if you see an affected mom and about half their sons and half their daughters affected, you should be thinking X-linked dominant. So an example of a disorder that follows this inheritance pattern is called Fragile X syndrome. Okay. What Fragile X syndrome is, it's literally what the name says. A piece of the X chromosome is fragile. So a piece of the X chromosome may have broken off or is deformed in some way to make it considered fragile. Okay. So on the right side of the screen here, you can see pictures of what those chromosomes might look like that are affected by Fragile X syndrome. On the left side are some characteristics of Fragile X syndrome. So usually we see a difference in facial features in people that are affected with this disorder. So usually the facial features are a little more elongated, okay? And eyes are generally a little more squinted, I guess you could say, or more thin, kind of like coin slot eyes is another indicator of Fragile X syndrome. Okay, so that genetic disorder is a dominant, X-linked dominant. So if you have a bad X chromosome there, you're going to pass it on to the children. Now for X-linked recessive, okay, things you're going to look for. First is that males are going to be affected more than females. The second thing, affected sons are usually going to be born to unaffected carrier mothers in this case. So that means that if you look at that pedigree, it's going to look like the trait skips a generation. So if you've got a mom that is unaffected, then she has sons that are affected, it's going to look like that trait skipped that mom's generation. Now, about 50% of a carrier mother's sons are going to be affected. And this one is super important to identify an X-linked recessive. Okay? You are never, ever, ever going to see an X-linked recessive pass from father to son. So if you are thinking X-linked recessive, you cannot have anywhere on that pedigree a father passing a trait to a son. In addition to that, really these last two bullet points here are probably the most important in identifying an X-linked recessive. All daughters of affected fathers are going to be carriers of an X-linked recessive disorder. So some examples that follow this pattern are colorblindness and hemophilia. So we talked about those earlier in this chapter as well. Those are two that are linked to the X chromosome, and they are recessive traits. So you need to have two bad copies of that in order to develop that trait. Now this one, Y-linked dominant, is a little more unique, okay? Because remember, the X chromosome is much bigger than the Y chromosome. Okay, so more traits are generally going to be carried on the X chromosome than the Y. So this is specific to males. Okay, only males can be affected by this because they're the only ones with a Y chromosome. The trait is going to be passed from the father to all of his sons because one, it's a dominant trait, so you only need one bad copy to show it. And if a father is affected, he's going to give it to all the sons because the father gives the Y chromosome to the sons. That's how they are identified sex-wise as a male. It's also not going to skip generations because it is a dominant trait. And an example of this, these examples are super hard to find for a Y-linked dominant. Okay, so this is a very obscure example. Okay, it's a disorder called hypertrichosis pinnae oris. So this is a disorder where the hair on the ears grows more than normal. Hypertrichosis in general is a disorder where hair grows abnormally, but the one that's Y-linked dominant is specifically the one where the hair grows abnormally on the ears. So we usually see this in men of Middle Eastern descent is the most common people affected by this. So it is not a debilitating disorder by any means, but it is just identified by there being extra hair growing on the ears. Now, like I said, hypertrichosis is like a whole category of disorders where hair grows abnormally, so it's sometimes called the werewolf syndrome. So you may have seen some pictures of people like this on TV shows and stuff before. Not a debilitating disorder, like I said, but it is something that they are able to live with, but they might use some kind of cosmetic surgery or something to get rid of it. So, in your notes, you've got some examples of pedigrees that I would like you to take a moment to identify what those pedigrees are showing using the checklist that we've gone over. Okay. So this use these checklists to figure those out, and then check your answers with